Hey, what's going on, guys? So today we're going to start a lesson on inequalities, which are very similar to equations, except they just have a few differences. Okay, so before we actually get into like the mathematics of it, you really want to be able to read inequalities and truly understand what they're talking about, because in the long run, it's going to help you out when you're solving them, plotting them on a number line, so on and so forth. So let's just say we have an equation, okay? And we'll review what makes an equation up is that an equation is two expressions, but we normally call them the two sides of the equation. And inside, or in the middle of them, is an equal sign, okay? Hence the equals, or the equations part. You have a left side of an expression, right side of an expression, joined together by our equal sign, okay? So if I were to ask you that what would be our solution for this equation, you would tell me that x equals 3, okay? That's the only solution there is. So when it comes to equations, there is one solution. Oops. All right. So there's one solution when it comes to equations. The other thing when it comes to equations is there's only one symbol, which is our equal sign. Okay? Which is the equal sign. Everyone knows that. Okay? Now, when it comes to inequalities, if you guys remember from your last 2 years ago in Algebra 1, is that inequalities look a little different, okay? So here's just an example of an inequality. We still have two sides, two expressions, the left and the right side. The only difference here is our symbol in the middle changes, okay? When it comes to inequalities, there's actually 4 symbols. Okay, and I'll write them all out here. I'll draw the symbols. So, they're very easy to understand once you actually understand how to read them. But again, reading them is the most difficult part, okay? So, if we look here, we're going to read left to right. This reads that x is greater than 3. So this is our greater than, okay? If we read this one, again, we're going to read from left to right. It reads x is greater than or equal to 3. Okay. This inequality symbol, if it has a line underneath it, aka a half equal sign, it means there's equality inside the problem, inside our inequality symbol. So this is x is greater than or equal to 3. Okay. Again, here this is less than. And this symbol is x is less than or equal to. So again, you would read the fourth one, x is less than or equal to 3. Okay. Again, because there's the little half equal sign on the bottom, so there is equality in this inequality symbol. Okay. One of the shortcuts, one of the ways for the kids to remember is what's greater than, what's less than. Think of this symbol as a mouth. Okay. When you're hungry, you want to eat the bigger portion. So whichever way the mouth is facing is your larger quantity. So in this case, x is greater than 3. X is greater than or equal to 3. The mouth in this one's pointing towards the 3, so x is less than 3. This one, x is less than or equal to 3. Okay? But in reality, the only thing that's changing in any of these 3 problems is our solution. Because when we talk about inequalities, the one thing you have to remember is that what is the answer telling us? What exactly is going on? Okay? So if you read, again, we'll read an inequality symbol. And if we look here, this is telling us right here that x is greater than 3. So we have to think, what can our solutions for x be? Well, let's think of something's greater than 3. There's 4, there's 5, there's 6, there's 10, there's 10 billion. Numbers keep going on and on and on to positive infinity. So in reality, the amount of solutions for an inequality are infinite. Okay? That is the largest difference between an equation and an inequality. Equations have one solution, no solutions, or infinite solutions. Inequalities have infinite solutions or no solution. Okay? So that's really the only difference when it comes to equations or inequalities. And being able to read them is very, very, very important, especially when it comes to our solution sets. Okay, so what we're going to do here is we're just going to start off with an easy problem. And we have 3x plus 5 is going to be greater than 17. Okay, again, when I said in the beginning that equations and inequalities are very, very similar, you solve them in very similar manners. Okay, so let's just say this was an equation. 3x plus 5 equals 17. The first thing you would do is subtract 5, because we want to isolate the 3x. And the inverse of plus 5 is minus 5. So now we have 3x is greater than 12. Then, to isolate x, since the 3 and the x are being multiplied, you're going to do 12 divided by 3. And you get x is greater than 4. Okay? Solved it the same exact way you would in an equation, except the only difference is that instead of an equal sign, we have an inequality symbol. And this one happens to be greater than. The only difference between equations and inequalities is that now we have to graph our solution on a number line. The way I like my number lines is you put the number, or our important number I like to call it, in the middle. Then you give me one number less, one number greater than, and we're good to go. Okay? But to get our answer, we have to kind of think back to what does this symbol mean? Okay? Well, when x is greater than 3, is there any equality in this? And the answer is no, because x can't equal 3, but x can be greater than 3. Okay, so we can get really, really, really close to 4 for this example, since x is greater than 4, but we can never actually get to 4. So there's something we have to do on the number 4 on a number line to represent that we can get really, really close to it, but not actually on it. So what you're going to do is you're going to draw an open circle on 4. Okay, that's your first step. It's going to be an open circle. It's going to be a closed circle. The next thing you want to do is we have to shade to the left or to the right. What I like you to do is read this symbol. X is greater than 4. Then think, is 3 greater than 4, or is 5 greater than 4? 5 is greater than 4, so we shade in 5's direction, and that's that. There's your answer. 5 is greater than 4, and here is your full solution. We have our answer, x is greater than 4, and then our number line. It's actually that easy. There is one little trick, which I will talk about now. Okay, 3 is, let's say, less than or equal to... let's say 12. Okay, so we have negative 2x plus 3 is less than or equal to 12. Again, we're going to solve this just like we would in an equation. Okay, so we're going to subtract our 3. Then we have negative 2x is less than or equal to 9. Okay, then in order to isolate the x by itself, we need to divide both sides by negative 2. So now we're going to get x and negative 9/2. Okay, here's where a trick comes in. It's not really a trick, it's just something you have to do. Since we divided both sides by a negative and changed both signs of the inequality, we must flip our inequality symbol. Okay, originally we started with a less than or equal to. When you divide by the negative, you must flip it to a greater than or equal to. Again, that is probably the only difference in solving equations and inequalities, is that when you divide by a negative number, you must flip your inequality symbol. Okay, so we have negative 9/2. Negative 9/2 comes out to negative 4.5. So a number less than that would be negative 5. A number greater than that would be negative 3. It doesn't not matter how far away each of these numbers are, as long as this one is less than the number we care about, this one is greater than the number we care about. Okay, so now we can go back. Let's look what our symbols mean again. So right here we have x is greater than or equal to 3, greater than or equal to. Okay, this inequality symbol gives us equality. So that means that in our problem, where x is greater than or equal to negative 9/2, that means that negative 9/2 can be a solution, because x can be equal to that. So again, like our last problem, the first thing you always want to do is put a circle on negative 9/2. But since there's equality in this problem, we can put a closed circle. Okay. The next thing, do we shade to the left? Do we shade to the right? Let's read this. X is greater than or equal to negative 9/2. What number is greater than negative 9/2? Negative 5, negative 3. -3 is the winner, and you shade to the right. Hopefully it seems pretty straightforward. Nothing too crazy. All right, let's try another one. 2x plus 6 is less than or equal to 3x plus 12. Okay, so again, this one's a little more difficult since we have variables on both sides, but in reality, it's not going to change anything. So let's solve this like we would an equation. Let's move all our x's to the right so they stay positive. Okay, so we subtract 2x from both sides. You have x is less than or equal to x plus 12. Get x alone, so you must subtract 12. And you have -6 is less than or equal to x. Uh-oh. The only difference here between our last two problems is that our variable x is on the right side. Now, a lot of people get worried because they like the x being on the left side. And I totally understand that because that's what we're used to seeing. But basically, we're just going to do English a little backwards here. Because normally in the English language, we read left to right. When it comes to inequalities, so you don't mess yourself up, always read from the side of the variable. Okay? So if the variable's on the right, you're going to read right to left. The variable's on the left, you read left to right. So let's first look what kind of circle we're going to put at -6. Since there's equality, since x is greater than or equal to -6, there's going to be a closed circle. Now let's read this to see where we're going to be shading from right to left. X is greater than or equal to -6. It's greater than since the mouth is opening towards the x, which means x is a larger quantity. So again, it's x is greater than or equal to -6. Which number is greater than -6? -7 or -5? I'm going to go with -5. Because I'd rather owe you $5 than owe you $7. Okay? And that's our equation on the number line. Okay? The last problem I want to do is -x over 2 is less than 26. Okay? This is a very simple problem, but I have a reason for doing it. Now, if we were to solve this algebraically, which we will be, and it was an equation, in order to get rid of this -1/2, or the -2 on the denominator, we must multiply each side by just multiply each side by -2. That way we can cancel it out. We're left with x is less than, oops, that's where I just messed up, x, and then on the right side of the inequality, we're going to have -52, okay? Just like the last, not the last problem, 2 problems ago, when you divide by a negative, you flip the inequality symbol. Likewise, when you multiply both sides by a negative, you flip the inequality symbol. So now it's x is greater than -52, okay? So that's the one thing you have to remember. When you multiply both sides by a negative, you flip the inequality symbol. When you divide both sides by a negative, you flip the inequality symbol, okay? So again, make your number line, put one less here, or a less number than the number we care about. Then to the right, you put a number more than we care about. If you read this from left to right, since our variable's on the left, it says x is greater than -52. There's no equality in it, so we have an open circle. And x is greater than -52. -51 is greater than that. So we're going to shade to the right. Okay. All right, guys, that in a nutshell is how you solve inequalities. Probably the most important thing when it comes to inequalities is reading the inequality itself. How can you turn this math into English you understand? And as long as you remember which side means greater than, aka where the mouth is opening up. Those are supposed to be teeth. Also, knowing that if there's a solid line underneath the arrow, it means there's equality. Because every single one of these problems is going to have a different solution. Whether it's an open circle, a closed circle, shading left, shading right. And remember, like in our third example, always read them when you're figuring out where to shade, starting with the variable. So if the variable's on the right, read right to left. If the variable's on the left, read left to right. So, in a nutshell, that's solving inequalities. Hope you guys have fun. Hope you learned some. If you didn't, make sure to look through this again, the video, since you can stop it, pause it, rewind it, and check out the document section for some practice.